In this video, I'm going to show you how to figure out which term number takes a certain sum of an arithmetic series to a certain total or over a certain total. So in this question that I am using as an example of how to do this, you're asked to find which term number of this sequence that I have here is going to take the sum of the terms over 10,000. Now realize that right now, the first term is 15, second 35, and fourth 55. Right now the sum of the three terms that you can see is already 105. We're looking to make the sum over 10,000. Okay, so the first thing I did is, instead of saying equal to 10,000, I'm saying equal to 10,000, and I'm using the summation formula for arithmetic sequences, which is n times the first term n times the quantity, first term number, plus a of n divided by 2. Now, I have to do some work to find a of n because I don't right now know what a of n is. And so what I'm going to do is use the explicit formula for arithmetic sequences to find out what a of n is, because I don't know what term number it is. And so how can I know the value of that term? And so all I did was the formula for arithmetic explicit is the first term, which is 15, plus 20, that is the common difference if you look at these three terms, times n minus 1. Now I'm just doing some simplification of this, so I did 20 times n and 20 times negative 1, and that gave me 15 plus 20n minus 20. And that simplifies down to a of n equals 20n minus 5. I'm going to insert this or substitute it in right here where it says a of n. So now it's 10,000. I change this to equal n times the quantity, 15 plus, and then this represents a of n, 20n minus 5. That's what I had simplified it to. And of course all of that is over 2. So my first step is I'm going to get rid of this fraction, and to do that I'm going to multiply both sides of my equation by 2. This is step 3, it's not part of the problem. This is step 1, this is step 2, this is step 3. Well, when I multiply 10,000 times 2 I get 20,000. When I multiply this times 2, then this cancels out because 2 divided by 2 is 1. And so now this is just n times the quantity 15 plus 20n minus 5. I'm going to go ahead and use the distributive property here to expand this. So the first thing I did was went ahead and simplified. Instead of writing this out as 15 plus 20n minus 5, I combined the negative 5 and the n, and then I distributed. 15 and negative 5 is 10, so that becomes n times the quantity 20n plus 10. N times 20n is 20n squared, and n times 10 is 10n. So now I have 20,000. I got that from multiplying 10,000 times 2 equals 20n squared plus 10n. Now I want to get it in expanded form, so I need to get it equal to 0, so I subtract 20,000 here and subtract 20,000 here, and I have 0 equals 20n squared plus 10n minus 20,000. Well, now I can use the quadratic formula on this because I have my b, this is my coefficient a, and then this is my c term, which is why I wrote it in this form, getting everything over here onto this side. So the opposite of b plus or minus b squared minus 4ac all over 2a. So the opposite of b, which is 10, and so before I did any of this, I went ahead and divided everything by 10, because you can see that all of these are factors of 10. And so that gave me 2n squared plus n minus 2000. And then I used these terms in the quadratic formula. And so I just want to go back over that. I made this here by subtracting 20,000 on each side. Then I factored out a 10 from each of these terms, and that gave me 2n squared plus n minus 2,000. It just makes it easier to work with. Okay, so now n is 1, so the opposite of 1, plus or minus 1 squared minus 4 times a, which is 2, times c, which is negative 2,000, all over 2 times a, and a is 2, so 2 times 2. Whoops. I did not finish the problem. So my next thing I have to do is actually do this math here. So here I'm showing that I entered on that last screen. So it's the opposite of B. I'm going to turn this around so I can use my pointer. The opposite of B, plus or minus. I'm ignoring the minus because it's a term number, so it's not going to end up to be a negative term number. So I'm really just doing plus. The square root of 1, which is really 1 squared, minus 4 times a, which was 2, times c, which is negative 2,000. And then all of that is divided by 4, and I got 30. Well, so it's about the 31st figure. There can't be partial figures in an arithmetic or a geometric series, so that means that at the 31st figure, it's equal to 10,000, which means it's going to have to be the 32nd figure that pushes it over that number. Now in the same video, I'm going to go ahead and show how to use the summation formula, because Yobi had asked me to find the sum. So let's look at finding the sum at the 31st and the 32nd term. Okay, so let's say I want to do the sum of the first 31st. Then, sorry, I'm going to erase that. Then I'm going to put 31 here, and I'm going to do a of 1, which was 15, plus, now I don't know the value of the 31st term, and so I'm going to do that over here. And so I have to use my formula again for finding the value of a term number. I'll use the explicit formula, which is the first term number, which is 15, plus the common difference, which was 20 times n minus 1, and it's 30, if it's 31 minus 1 is going to be 30, so I'm going to do that. I'm going to do 20 times 30. I know that 2 times 3 is 6, so this is going to be 600. And then I'm adding 15 to that, so 615 should be my 31st term. So I'm going to write that differently. So A of 31 is 615. And then we're going to divide that all by 2. So now I have to add those two together, which is 630. And now I'm going to do 31 times 630, and then all divided by 2. And I have my calculator here. 630 times 31 is 19,530. Whoops. 530 divided by 2 gives me 9,765, and so that's the 31st term. Now let's try the 32nd term here, and I'll show you again the same exact thing using that one. So this time it's going to be n times 15 plus a of n, all divided by 2. I'm going to do the half screen again. So a of 32 is equal to 15 plus 20 times 32 minus 1 is 31. And then now I'm going to do 20 times 31, which gives me 620. And so if I add 15 plus 620, that's going to give me 635. So the value of the 32nd figure is 635. I can put that in here now. So I'm going to do... Okay, sorry, the dog is laying here by me and he's making funny noises. He's just dreaming. He's happy and fine. He's on the couch with me. Okay, so n is 32. It's this 32nd term. Making funny noises. And it's the first term plus, we said the value of the 32nd was 635. And then all of that is going to be divided by 2. So 635 plus 15 gives me 650. So now I'm 32 times 650. All of that divided by 2. And then, so if you do times 32, you're going to get 20,800. And then if you do that divided by 2, you're going to get 10,400, which proves that the 32nd term is the term number that pushes the sum over 10,000. So we've done two things in this video. I've shown you how to find a term number by substituting things into the summation formula and using the quadratic formula. And I've also shown you, based on Yobi's request, how to use the summation formula to find the sum of some number of terms. In this case, I found the sum of the first 31st of all 30, I can't say it, of the first 31st terms and the first 32 terms. All right, have a great night. We'll talk to you later. Bye.